Good morning, students. In the last class we discussed the numericals on the basis of Angst modulus, and the today class the fourth numericals I am going to explain. Listen here. In the last class also we discussed the Angst modulus. What is the Angst modulus formula? Angst modulus is equal to FL by A into delta L. In this today class also on the basis of Angst modulus. Why? Because many times they asked on the basis of Angst modulus only. That's why I am going to solve the more numericals on the Angst modulus. In the CET, NEET as well as in the JEE, the maximum questions they asked from the Angst modulus. That's why I am going to solve these type of numericals also. Listen here, on these numericals, the four identical hollow cylindrical columns. Let us consider four identical hollow cylindrical columns that is made up from steel materials, supported a big structure of mass 50,000 kg. Those four identical hollow cylinders which is supported from the big structure of mass that is 50,000 kg, and those cylindrical columns, the inner radii and outer radii are 30 centimeter and 60 centimeters respectively, assuming that the load distribution to be uniform. Among these four identical hollow cylindrical, the load distribution is uniform, equally distributed. Among these four hollow cylindrical columns, this 50 kg mass is distributed uniformly, equally. Then we should calculate the compressional strain of each column. We should find the compressional strain, how much that is the cylindrical columns are going to compress by adding that much of mass on each columns. That steel is more elastic. If suppose the mass is acting on those cylindrical columns, that much of mass is equally or uniformly distributing among each four identical columns. The compressional strain, that is we should find the compressional strain. Listen here, before going to explain that compressional strain, what are the things they mentioned? Write clearly. Given, always should write given values very clearly. Four identical hollow cylindrical columns that is made up from steel, and big structure of mass, that is mass. This we can also say that the total mass supported by four identical hollow cylindrical columns, that is 50,000 kg. Okay. Now this mass is distributed on each cylindrical columns, means we can say that mass on each columns, that is total mass is 50,000, and how many columns are there? 4. Just distribute it, that is 12,500 kg on each column. Mass is acting on each column is 12,500 kg. Why? Because ultimately we should calculate the compressional strain on each columns, not in total all four columns. We should find the compressional strain on each columns only. This is the first thing they mentioned. Then inner radii and outer radii. Inner radii, Ri, you should write inner radii. How much? That is 30 centimeter. Or we can also write Ri, which is equal to 30 into 10 raised to minus 2 meter. And outer radii, just to mention, outer radii, RO, outer radii, which is equal to 60 centimeter. 60 centimeter, we can also write like this, 60 into 10 raised to minus 2 meter. Then assuming that the distribution to be uniform, equal in all the columns uniformly, that is 12,500 kg, then they mention the Angst modulus of steel also. Angst modulus of steel, which is equal to 2.0 into 10 to the power of 11 Pascal. In the last numericals, we used Angst modulus of steel is equal to 200 into 10 to the power of 9. This is Newton per meter square. Newton per meter square is nothing but a Pascal in terms of pressure. They mentioned in terms of pressure. And the power variation, these two zeros add here. What happens? Angst modulus of steel is equal to 2 into 10 to the power of 9. Just the variation of powers, 10 to the power of 9 only. We can write 200 into 10 to the power of 9 or 2 into 10 to the power of, this is 11, and if 9 means it is going to increase by 11. 2 into 10 to the power of 11 Pascal. And 1 Pascal is nothing but 1 Newton per meter square, or you just convert. If you don't want in terms of Pascal means you just convert 2.0 into 10 to the power of 11 Newton per meter square. Okay, we should find the compressional strain. We know that the modulus of elasticity means modulus of elasticity or Angst modulus, general formula for Angst modulus. Angst modulus, which is equal to longitudinal stress by longitudinal strain. Longitudinal means we are considering about the length. Longitudinal stress by longitudinal strain. Shall we consider this Angst modulus? This is Y, Angst modulus of steel. Just instead of longitudinal. Why? Because in this also the length is going to variation. Initially this much of length. After applying a certain mass, this length is going to compress. We are discussing about the length only. Shall I take directly? This is stress by strain. Stress by strain. Inner radii is 30 centimeter. Outer radii is 60 centimeter. We should write like this: area is equal to pi into outer radii square minus inner radii square. We can write like this. Before going to substitute this, we can also convert this area also before going to substitute the values, or before going to substitute the values we can write like this. Listen here. Angst modulus is equal to what is stress? Force acting per unit area by strain. We want strain which is equal to force by area, and this Angst modulus will come this side, Angst modulus of steel. Now area we can write like this: force by pi r square into Angst modulus. Now this area we can also write like this: Angst modulus of steel, which is equal to Angst modulus we took this side. Now strain, which is equal to what type of strain? That is compressional strain, which is equal to force. Keep as it is. Just first you convert the radius. Shall I write like this? Pi outer radii minus inner radii into Angst modulus. This is the total radii. Now they mention inner radii and outer radii separately. Now substitute the values. Force is how much force? 1,25,000 by pi is 3.142, and this is R naught square. R naught square means outer radii is RO square, 60 squares. Just to mention, 60 centimeter means 10 raised to minus 2 whole square, minus Ri square means inner square, that is 30 into 10 raised to minus 2 whole square. Are you better write clearly here? Or we can also find directly by substituting here only. how to find means, shall I calculate here? Area is equal to pi into, that is inner radii means 60 into 10 raised to minus 2 whole square minus 30 into 10 raised to minus 2 whole square. First you calculate this, and we know that the pi value, that is 3.142, pi value 3.142 means that is this is we can convert that directly, or power values 60 square. How much the 60 square? Or you calculate from the calculators directly, how much is the answer? That is on each columns is, substitute this directly. That is force is, how much force? 1,25,000 by 1,25,000 by pi value is 3.142, and RO value is outer radii. Outer radii, how much outer radii? Just they mentioned outer radii is 60 centimeter square. 60 centimeter, R naught square, 60 square, or you write 60 square means 3,600 into 10 raised to minus 2 square means, that is 10 raised to minus 4. R naught value is 60 into 10 raised to minus 2 meter. R naught square means 60 into 10 raised to minus 2 into 60 into 10 raised to minus 2. 60 into 60 means 3,600 into, bases are same, power should be added, that is 10 raised to minus 4 meter square, that is radius square in terms of meter square, just to mention. Similarly for inner radius square, 30 into 10 raised to minus 2, we can also write Ri square, which is equal to 30 into 10 raised to minus 2, 30 into 10 raised to minus 2. This is the square value, that is 30 into 30 means 900 into 10 raised to minus 4 meter square. Here is 900 into 10 raised to minus 4. Now, what is the Angst modulus of the steel rod? They mentioned Angst modulus 2 into 10 to the power of 11. 2 into 10 to the power of 11 Pascal or Newton per meter square. Ultimate strain value is strain, which is equal to how much strain, compressional strain acting, that is 7.2 into 10 raised to minus 7. 7.2 into 10 raised to minus 7. Is there any unit? No. Strain means no unit. This is compressional strain is compressional strain on each column is 7.2 into 10 raised to minus 7. If you want total means, just to multiply into 4, that much of compressional strain is acting on the 4 columns. They mentioned this much of given values. By using those given values, we are going to find the compressional strain on each wire is, that is 7.2 into 10 raised to minus 7. The compressional strain is, that is 7.2 into 10 raised to minus 7, or by calculating this is approximately, that is 7.3 is just to calculate yourself on the calculators. That is approximately compressional strain is 7.3 into 10 raised to minus 7. 7.3 into 10 raised to minus 7, approximately 7 into 10 raised to minus 7. That is negative values, that is very much smaller value. Come to the next question. Next question on the basis of shear modulus. We know that the formula for shear modulus, and also we discussed the concept of shear modulus also. Now, what is shear modulus? Shear modulus, which is equal to shearing stress by shearing strain or tangential stress by tangential strain. Tangential strain. Here the notation for shear modulus is neta. Stress is always, we know that force acting per unit area, and strain, that is change in length with respect to original length. Why? Because here a shape is going to change. That is neta is equal to FL by A into delta, and already we know that this is the formula we are going to use on this question number 4. What is question number 4 means? You write simultaneously question number 4. Sorry, that is question number 5. Already we discussed the question number 4. This is question number 5. That is the edges of aluminium cube. The edges of aluminium cube is 10 centimeter. The edges of aluminium cube is 10 centimeter long. One face of the cube is firmly fixed. The one face of cube is firmly fixed to a rigid support, any or vertical wall, fixed to a wall. One face of the cube is fixed to a wall. The mass of 100 kg, mass of 100 kg is then attached to the 100 kg, then attached to the opposite face of the cube, opposite face of the cube. In the bracket they mention we should find, what are the things should find here means the edges of aluminium cube is 10 centimeter long. The one face of the cube is firmly fixed to the wall. The mass of 100 kg is then attached to the opposite face of the cube. The shear modulus is 25 gigapascal. They mention the shear modulus is 25 gigapascal. Shear modulus is 25 gigapascal. What is the vertical deflection of the face? what is the vertical deflection of the face This is our question. What is the vertical deflection of the face? This is our question. Now we should find the vertical deflection. Just keep in your mind, what is vertical deflection? What is the meaning of that vertical deflection? Means that is vertical deflection on the opposite face. Just to convert this for question in the form of diagrams, just to consider a cube. Just to consider, this is our given cube. This is a cube. The edges of this aluminum cubes are how much? 10 centimeter long. This is the edges of aluminum cube is 10 centimeter long. Let us consider this is the one face of the cube is firmly fixed to the wall. This is fixed to the wall. Another face attaches a load attached to the opposite face of the cube. This face is fixed to the wall and opposite face is attached to the how much mass? 100 kg. This is 100 kg's mass is going to attach to the opposite face. Definitely its shape is going to change. Initially the cube is like this. If suppose mass is attached, definitely the cube shape is going to change. This much of mass is acting on the opposite face means the shape is going to change. We should find how much deviation, delta L. How much deviation? This is vertical reflection is nothing but vertical deflection means delta L we should find. Vertical deflection on the cube means we should find the delta. What are the things are given? Edge of an aluminum cube. Edge, that is nothing but length we should consider, that is L is equal to 10 centimeter, or we can also write 10 into 10 raised to minus 2 meter. Or if suppose I am considering this is 1 means bases are same, power should be added, that is 10 raised to minus 1 meter, or we can also say that 0.1 meter. The length is 0.1 meter. Then mass is 100 kg. Mass is 100 kg, that is M is 100 kg. Attached opposite face. The modulus of shear modulus, that is neta. Neta is nothing but shear modulus. Shear modulus, which is equal to 25 gigapascal. Already we know that 1 Pascal, which is equal to 1 Newton per meter square. Pascal is nothing but Newton per meter square. We can also write like this, neta, which is equal to 25 into giga means 10 to the power of 9 Pascal or Newton per meter square. And this is the things we should find the delta L. How to find delta L? By using shear modulus. Just general definition for modulus is modulus or moduli. Modulus is equal to stress by strain. Stress by strain. If Angst modulus means longitudinal stress by longitudinal strain. The shear modulus means tangential stress by tangential strain. Now this tangential stress we can also write like this, tangential strain we want. Tangential strain which is equal to tangential strain which is equal to tangential stress by shear modulus. Don't confuse, you can also write instead of this tangential stress by tangential strain, shear modulus, shear stress by shear strain. In some of the book they mention shear modulus is equal to shear stress by shear strain. We can write shear stress by shear modulus. Now stress is equal to force acting per unit area. Modulus is neta. Now force acting per unit area into neta. This is called as tangential strain, or we can also considering as both are same, shear strain. Tangential strain or shear strain you can also consider. Now substitute shear strain which is equal to force is, how much force is acting? Now only we calculated, that is 980 divided by area, how much area? Now only we calculated area length into breadth, that is 0.01. And what is the shear modulus? That is 25 into 10 to the power 9 giga, 10 to the power of 9 Pascal. Now the final answer for shear strain is shear strain which is equal to 3.96 into 10 to the power of minus 6. Just calculate yourself. I mentioned the final answer, that is 3.96 into 10 raised to minus 6. This is about shear strain. We know that already. We know that shear strain which is equal to lateral strain by one side of any cube. Lateral strain by, lateral means change in its diameter. Diameter is going to change by adding this much of mass. Lateral strain by one side of the cube. Any cube. This is the general formula. Now lateral strain, we want vertical deflection is nothing but lateral strain, that is change in length. Or you convert this lateral strain, or you can also write like this, shear strain, vertical deflection means delta L. Already I mentioned delta L. What is general formula for strain? Strain which is equal to change in length by original length. Now we want delta L which is equal to strain into length. What is strain value? Shear strain value, that is 3.96 into 10 raised to minus 6. And what is length? That is 0.1 meter. Just add it one more, 10 raised to minus 1, that is 3.96 into 10 raised to minus 7. This is the final vertical deflection on opposite side of that cube. After applying 100 kg of mass, the vertical deflection is 3.96 into 10 raised to minus 7. There is no unit for strain quantities. This is about numerical, just note down. Or you can say that approximately that is 4 into 10 raised to minus 7. Okay, next numerical. Is it clear? Okay, we'll move to next numerical, that is question number 6. Numerical number 6. Before going to solve the numericals, you should add the formulas, or you understand the formulas and terms explanation very clearly. Then only it is very easy to solve the numericals. Next one is a piece of copper, that is sixth one. Next one is a piece of copper having a rectangular cross-sectional area of, that is 15.2 mm into 19.1 mm is pulled in a tension with 44,500 Newton. It is nothing but force. With tension, force producing only elastic deformation, only elastic deformation, calculate the resulting strain in the bracket they mention the given values, that is shear modulus of copper is that is 42 into 10 to the power of 9 Newton per meter square. The shear modulus of copper is the piece of copper having a rectangular cross-sectional area is, that is length into breadth. They mentioned in the form of length into breadth in terms of millimeter, is pulled in a tension with a force that is 44,500 Newton. The force produced only elastic deformation. That much of force is produce only elastic deformation. Calculate the resulting strain. Resulting strain means we should find the strain. Just only you mention the formulas, or before going to solve the numericals, you just write the given values very clearly. The first one is area, that is area which is equal to length into breadth, that is 15.2 mm into 19.1 mm, that is millimeter. This is around area which is equal to 15.2 milli means 10 raised to minus 3 meter, and this is 19.1 into 10 raised to minus 3 meter. Bases are same, power should be added, multiplying factors, we should add the powers. Area which is equal to how much area? That is area is equal to around you calculate area directly. They mention 15.2 into 15 point, directly you mention in that question, or you better you substitute directly. What is the next given values? That is the mass which is equal to 44,500 Newton, and shear modulus of copper, which is equal to 42 into 10 to the power of 9 Newton per meter square. Now we can convert this mass in terms of force. Mass in terms of force which is equal to mass into acceleration due to gravity. Mass is 44,500 into acceleration due to gravity is 9.8, or you consider directly nearly about 10. How much? F, which is equal to 445,000 Newton. This much of force is acting on that piece of copper. Now what is the formula? Shear modulus, which is equal to shearing stress by shearing strain. Already we know this formula. We want resulting strain. We want strain which is equal to stress by shear modulus. What is stress? Force acting per unit area into this shear modulus. Now force is how much? 445,000 divided by area. Means how to find the area? Already they mentioned directly. Area is equal to 15.2 into 10 raised to minus 3 into 19.1 into 10 raised to minus 3. This is area. Into neta is shear modulus 42 into 10 to the power of 9. You just calculate by using calculator separately by denominator and then you divide it. Now the final strain answer is strain which is equal to, I calculated here, the final strain answer is 3.65 into 10 raised to minus 3. 3.65 into 10 raised to minus 3. This much of strain is acting on a piece of copper, producing only elastic deformation, not a plastic deformation. We should calculate the resulting strain is equal to 3.65 into 10 raised to minus 3. This is about today class numericals. I am going to explain in the next class I am going to explain the numericals on the basis of bulk modulus. Thank you.